All right, so a little review on 5-5, and then we'll do a little bit of 5-6, and finish up 5-6, and continue on with 5-7, which is basically more of the same. What should be the first step of factoring this ugly polynomial?
Four xy goes in all of them.
What's that?
4xy goes in all of them.
Yep. So we're going to pull out, what's it called?
Lowest common, or the greatest factor.
GCF. GCF. So we're going to pull out the greatest common factor, which is 4xy. And I just wrote 8. 4xy. What's left behind? 2x squared. Plus 5x. Minus 3. All right. Now don't quit there where you just pull out the greatest common factor. I've had people factor it this far and say, oh, that's it. What the directions for factoring are completely factor. Break it down as much as you can into smaller and smaller pieces. So what's the next step of factoring this? How do you factor a trinomial that starts off with a 2x squared? Multiply the beginning number, the 2, times the end number, which is the 3, and 2 times 3, of course, is 6. So you start with the 6, and you say factors of 6 that, in this case, subtract up to, because of this minus sign, to the 5. So what are factors of 6 that subtract up to 5? Factors of 6 that subtract up to 5. They add up to 5.
6 and 1.
6 and 1. So we're going to have to separate this into a 6x and a 1x. What kind of 6, what kind of 1?
Positive 6.
Positive 6 and negative 1. Bring down the negative 3. Bring down the 2x squared. We're just going to ignore the 4xy and realize we have to drag it back down into the answer later on. All right. From here, group the first two. What's the greatest common factor of those two? 2x. What's left behind? X plus 3. And if we GCF the second two, what can we pull out? A negative 1. You have to be able to pull something out. So if you can't pull anything, it's a 1 or a negative 1. What's left behind, though? Careful.
X plus 3.
Negative 3 divided by negative 1 is a positive 3. When you get stuck, do the little division trick, and it usually fixes all the signs. What can I pull out here?
X plus 3.
Yank out the x plus 3 and leave behind
2x minus
2x minus 1. Now don't forget that we pulled this out at the beginning, this 4xy. It does have to come back into the answer. And this is what we call completely factored. Broken down as many little pieces as possible. All right. So that's about as bad as they get in 5-5. What's the worst that they get in 5-6? Yeah, let's try this one. 32. 50x cubed minus 20x squared plus 2x. All right. It's the same basic type of thing, though they separate this in 5-6 and call it a special factoring, but you can do it exactly the same as you've done. What would you do first? Take out a 2x, the GCF. Left behind, 25x squared minus 10x plus 1. Because 2x divided by the 2x will leave you behind with 1. All right. How would you factor this one?
And
the same way.
25.
Well, don't add them. Multiply them. So 25 times this one way over here, obviously is going to be 25. So factors of 25 that add up to 10.
5 and 5.
5 and 5. So we get a 5x and a 5x. We need them to add up to 10, so they both have to be
Negative.
negative. Well, technically negative 10. And then bring down the 25x squared, and bring down the positive 1. And then just group and factor. GCF of the first two? 5x. Left behind? Careful. 25 divided by 5? 5. Yeah, 5x. Minus 1. Negative 5x divided by positive 5x is a negative 1. What's the GCF of the second two?
1.
Careful. If it starts off with a negative, you pull out negative. So it'll be negative 1. Left behind?
Minus
5x minus 1. Now when you pull out this 5x minus 1, what's left behind?
1. 5x minus 1.
Another 5x minus 1. So we're going to write this as 5x minus 1 all squared. And then don't forget that 2x that we pulled out at the very beginning. And there's your factor. All right, they consider that special because it comes out as a perfect square. And they give you a nice little formula if you want to memorize it in the book, but I highly suggest you don't waste your time and then just, factor it like normal. All right, so today, finishing up 5-5, we're going to do the other special factors. Not 5-5, 5-6. The rest of the special factoring. Some of them are easy. Some of them are hard. So we'll start off with the easy one. For instance, x squared minus 9. Now, if I'm going to set this up, I want to set it up like the factoring that we've done before. But we need 3 terms. What term is missing here? The x term. So how would I write this with the x term included?
X squared minus plus 0.
Plus 0
Minus
x minus the 9, right? Kind of like that long division where if you have a missing term, you would just replace it with 0. So, start all over again, factoring this. Factors of 9 and subtract up to 0. 3 and, well 3 and 3 add up to 6, so 3 and negative 3. 1 positive, 1 negative. So when we separate it, it goes x minus 3x plus 3x minus 9. She thinks everything's funny today. She's rich now, don't worry. GCF of the first two. Left behind? GCF of the second two. Positive 3, left behind? X minus 3. And then when we yank it out, it becomes x minus 3 and x plus 3. Has anybody seen the shortcut yet? I mean, it's pretty simple. You're picking a negative 3 and a positive 3, and then our answer is negative 3 and positive 3. Just remember, it doesn't work when the lead coefficient isn't 1. Because over here, we picked 5 and 5, and 5 is not in the second position at all. All right, so x squared minus 9 factors into an x minus 3 and a x plus 3. So what would you expect x minus 4 to factor into? X minus 2 and x plus 2. How about x squared plus 16? Yeah.
8.
Well, watch what happens. If I put that 0 back in, what are factors of 16 that add up to 0?
Negative 4.
Yeah, but they have to add. See, if you have negative 4 and plus 4, it's subtracting.
Negative 4 positive
But that's subtracting.
4.
Because you have opposite signs and you
said
subtract the
add.
numbers. I said add. Are there any numbers of factors of 4 that add up to 0? No. So the only thing you could do with this is leave it alone. It's considered prime. You can't factor it. So this only works if it's the difference of perfect squares. X squared is a perfect square, 9 is a perfect square, and they're subtracted. Because we need it to subtract up to 0, one be positive and the other one will be negative. But if it's positive, you just can't do it because it doesn't work. It doesn't have that same pattern. So we just consider it prime and leave it alone. We don't force the issue. So you might want to write down someplace that you can only factor the difference of perfect squares. You cannot factor the sum of perfect squares. Even though you feel like you should, you really can't. At least not over the real numbers. That comes later. Play around with that in the next class. All right, so if I give you something like, for example, 25x squared minus 49. With these, the size of the numbers really don't matter. Because 25 is 5 squared, 49 is 7 squared, x of course is squared, so this is just a bunch of squares. So here's the pattern. What happened to the x squared in our x squared minus 9? Well, it just split up into x and x. And the 9 split into 3 and 3. So what you just have to do is pull apart the perfect factors. So what makes 25? 5 and 5. X squared is x, and 49 is 7 and 7. So this is just going to factor into 5x minus 7 and 5x plus 7. If I put one of these on the test, you say thank you, because these are the ones that are nice and easy. They really are, until you get to that plus 1 and you try to factor it for some reason. Most people do. Even when I was learning this, I would try to factor that because you feel like you have to break everything apart. Be careful, things like this. If I ask you to factor it, can you? X squared plus 5x plus 1. No. Factors of 1 that add up to 5. Well, the only factors of 1 are 1 and 1, and they only add up to
2.
1 plus 1.
I thought you were multiplying.
Factors of 1 that add up to 5, and then 1 and 1, and they add up to 2. So this is considered prime. You can't factor it. There are no factors that exist to break it apart. All right, we can make this worse. 200x to the 4th minus, think here, 72y squared. Okay. I'm just making it as ugly as I can, because most of these are very nice and easy. What should you do first? GCF, even if it's simple like this, you really want to pull it out. First of all, 200 is not a perfect square. So what's the GCF? 8? I'm worried now. But that's okay. 200 divided by 8?
25.
25. So we're going to pull out, I'm going to pull out an 8. Left behind is 25 x to the 4th minus
7.
9
Oh.
y, we're not listening to you today, squared. I have different numbers in mind, but that's okay. That's perfectly fine. All right. 25 breaks up into 5 and 5. X to the 4th. X squared and x squared. 9, 3 and 3. Y squared, y and y. So when this breaks down, we're going to get 8 on the outside. What's the first term? 5. X squared minus 3, y. So the next term is going to be 5x squared plus 3y. Yeah. And that's all there is to difference of perfect squares. Just make sure it's a difference and not a sum. All right. Did they do the other one? They do. I might as well show you. Again, the book has a formula. I'd rather you not deal with a formula. It's more of a pattern. First, we need to multiply something together. X minus 2, x squared plus 2x plus 4. Multiply that together for me. A little reminder of how to multiply polynomials. Paper help. Sure. If you could do that in your head, it would be very nice.
Is the human calculator.
He don't know what he's doing.
I know.
I'm gonna do it in my head.
What'd you get? Oh, please. You didn't even say what it was first.
I did, that's what I thought. Cause the two, those are the negative 4 is that comes to the square. Every plus and minus. And then the negative 2 and 4 is x cubed. And then I'm better.
You don't have any paper.
You don't need paper.
Then what you got?
Everybody get x cubed minus 8?
Yes.
Oh. So, here's the thing. If we start off with x cubed minus 8, how do we go backwards and break it apart into those two, a binomial and a trinomial?
Very carefully.
It's very careful. So what we're going to look for is a pattern in that product. Look at the first term, x minus 2. Where would you get the x minus 2 from x cubed minus 8? Well,
X squared plus x.
what x times x, right? That would be x cubed. And we just took one of them. And there's our x. And 8 is 2 times 2 times 2. And we just took one of them. So we're basically cube rooting both of these and getting x and 2. Now, if you look at the first term here is x squared. The second term is 2x. Well, that's the same things as these two pieces here. One of them being an x and the other one being the 2. The only thing that changes is, instead of a negative, we're writing a plus. Where's the 4 coming from? Well, that's 2 squared. So basically it works out. Break this down into its primals. So you're taking away the cube and you're taking away the cube here and writing it as x minus 2. And then you're squaring the first term. You're multiplying the two terms together, changing the sign, and squaring the last term. And that gives you this trinomial. All right. So if I have x cubed minus, 64. Can you write 64 as a perfect cube?
Yes.
What is it?
8.
That's 8 squared. It's 4.
Yeah.
It's 4 cubed. So we can rewrite this as x cubed minus 4 cubed. So if we follow that pattern, you get rid of the cubes and you get x minus 4. That's your binomial part. That'll be the easy piece. The second piece comes from number 1, square. And you're squaring that first term. So whatever is sitting there, you just square it. So x squared is, well, x squared. Number 2, you're going to multiply the two terms that you're looking at. One's an x and the other one is 4. So 4 times x is? It'll be negative 4x, but over here you're going to write it as positive 4x. And then number 3, you're going to square this term. Now, when you square a positive and or a negative, the sign is always going to be positive. So whatever goes here is going to be positive. 4 squared is 16. And there you are. You have factored a perfect cube. How about y cubed plus 27. Can you write 27 as a perfect cube?
Yeah.
Yeah. This is y cubed plus 3 cubed. So the first term is going to be y. Why would it be minus? See, up here it was x minus 4. Here it's going to be plus 3. You just take it away. This one actually works plus or minus because when you cube a number, it doesn't matter if it's positive or negative, it keeps it the same. Negative 2 cubed is negative 8. 2 cubed is positive 8. So this will work. Start off with number 1. Take that y and square it, you get y squared. Take the two of them together and multiply them. It'll be 3y, but over here you're going to write it as its opposite. And then finally you're going to square the last term, so you're going to get a positive 9. And you're done. It's not that hard, it's just something you have to remember the small pattern built into it. So with perfect squares, you can only deal with the difference. With perfect cubes, it doesn't matter if you're dealing with a difference or a sum. If you multiply these two back together, you will get y cubed plus 27. So it works either way, and that's where it gets a little confusing. Second thing that gets confusing is I've seen people write this down as x minus 4, and the next thing they write is x plus 4. Don't confuse it with perfect squares. This one has to have an x cubed as the first term, so you have to have that trinomial. Oh, can we make it harder? Yeah. A little bit. Let's see if I can find a horrible one in the book. That's not too bad. That one's horrible.
Just watch the 15th power.
Well, you could. You could do 15th power. It wouldn't hurt. How about this one? X to the 5th minus 27x squared y cubed. X to the 5th minus 27x squared y cubed. First step,
GCF?
pull out the GCF, which is
X squared.
x squared. You need to get that out of there, otherwise this won't work. Left behind,
X cubed
x cubed
minus 27y cubed.
minus 27y cubed. If you have to do the one more step, write everything as perfect cubes. 27 is 3 cubed, y cubed. So when we factor this, that x squared stays out front. What's the first term? The binomial part. X minus 3y. X minus 3y. What's the second term start off with? X squared, because you're going to square that first term. Second term. Plus
3y squared.
3xy. Plus 3xy, because you're going to multiply these two together. That'll give you 3xy. And you're going to change the sign. And then finally, square the last term. Plus 9y squared. And you're done. Not that bad. Alright. Now the bad part is this. I start mixing and matching different types of factoring. For instance, I think this one works. 54. 16 m to the 4th minus 25. That might be wrong. Yeah. Let's see what happens. Make that. No, that won't work. All right. What can I do? Can I factor this first of all?
Yeah, take out 1.
Well, is it a perfect square or is it a perfect cube? It's a perfect square. So write them down as perfect squares if you have to. 16 can be written as
4 squared.
4 squared, so the first term will have a 4. M to the 4th can be written as m squared. Minus 25 becomes 5. And then the second term is
4
4
m squared.
m squared plus 5. Now here's the scary part. obviously 4m squared plus 5 will never factor because it's a plus. Is it possible in some weird way that 4m squared minus 5 could factor?
I'm guessing yes, because you asked.
It's possible, except the 4 works fine, the m squared works fine, except the 5 doesn't work really fine, over the rational numbers at least. But what if this number was 25? We got down here and it was 4m squared minus 25. Should we leave it? No, we need to break it apart as much as we can all the way through the problem. So don't quit until you come up with it's prime, it's prime, it's prime. Once you get down to them all prime, you're done. But if you leave a problem that looks something like this, let's say 9x squared minus 16, 9x squared plus 16. You get done, you factored the problem out, and you got down to this point. If you leave it here, you lose 2 points out of my 5 points that I give you. Why? Well, because this is the difference of perfect squares. And what does 9x squared minus 16 factor into?
3x minus 4, 3x plus 4.
So the final answer should be 3x minus 4, 3x plus 4. Can you factor 9x squared plus 16?
Yeah.
No, because it's not the difference of perfect squares. So you just leave it alone. 9x squared plus 16. And that would be what's considered completely factored.
What do you mean the difference of perfect squares?
Difference of perfect squares is the only one that factors. The sum of perfect squares does not factor, it's prime.
But what makes one different and one is all?
Difference? Sum.
Yeah.
Well, difference means subtract, and sum means add. All right, so that leads us into 5-7. Now, 5-7 is just everything else you've learned put together, and completely factoring has this thing built in. You're going to factor, and then there's going to be more factoring. So you might have to do the factoring like twice, maybe even 3 times. Oh, something simple. That one is not simple. Actually, those are all kind of boring. Boring. Did that. Jeez, why did they wait so long to do it? This is in 5-7. And 5-7 really isn't that much different, so we're just going to cruise through it quickly. Factor completely. Is the EL line? Yeah. Just doesn't look right. Factor completely. So, where did I find it? 34. 1 minus 16x to the 4th. One minus 16x to the 4th. If it's 2 terms, your question should be, is it a perfect square, is it a perfect cube? If it's a perfect square, your second question should be, is it a difference or a sum? And if it's a difference, it factors. If it's a sum, just leave it alone. It's not going anywhere. So it is a difference. So 1 is going to leave you with a 1, because 1 squared is 1. What gives you 16? 4. So this will be 4. What gives you x to the 4th? X squared. And then the second term would be 1 plus 4x squared. Now, are we done factoring? This is where you have to think, well, what do I have left?
2, 4x.
Does 1 plus 4x squared factor? No. So this is the one you want to concentrate on. So what does 1 minus 4x squared factor into? 1 minus 2x. And 1 plus 2x. And then just bring down the 1 plus 4x squared. What's funny is because of those first 5 sections, basically 6 sections, people will factor this and think they're done because they're used to factoring just once and being done with it. You have to be really careful to carry it all the way through the problem and make sure all of your pieces also do not factor. It's more words than that. It's on this page. Yeah, this one's nice. 36. 2x to the fourth minus 2x squared minus 24. What would you do first? Take out a greatest common factor, which happens to be 2. So kick out a 2. Left behind will be x to the fourth minus x squared minus 12. All right. Can you factor what's left on the inside? Yes. Well, at least we can try. Factors of 12 that. Subtract up to a negative 1, which would be 3 and 4. What kind of 3, what kind of 4? Positive 3, negative 4. They're both going to get what kind of 3 and what kind of negative 4? X squared. We need that to turn up to be a negative x squared in the top. So positive 3x squared minus 4x squared. Bring down the negative 12. Bring down the positive x to the fourth. A little hint, that first term has to be positive, otherwise this factoring technique becomes very messy. So if it's negative, just make sure you yank out a negative 1. All right, how do I factor that? Group the first two, what can I pull out? Do not group with parentheses. I bet some of you have already tried that. Pull out an x squared, left behind? X squared plus 3. GCF of the second two. Negative 4, left behind? X squared plus 3. Negative 12 divided by negative 4. And then we can yank out x squared plus 3, leave behind x squared minus 4. Don't forget the 2. Now, are we done? No. What's left that we can do? That x squared minus 4. So I'm going to bring it up here. So this becomes 2 x squared plus 3. And x squared minus 4 factors into x minus 2 and x plus 2. Oh, by the way, does it matter which order you put the minus and the plus in? No. Some people like putting the plus first and the minus second. It really doesn't matter. Is this completely factored? Can you factor x squared plus 3? No. No. Give me the 2 reasons. It's a sum is the major one. The other one is? It doesn't have a perfect square in that 3. 3 can't be broken down into the product of 2 numbers in the rational numbers.
Does it matter? It don't matter what, like, let's say that right there. That one. Well, not that one. That had to be something different. I know, like, on some of the homework, I was getting, like, the right answer, but it was different.
Oh, well, can you switch the order of multiplication?
Yeah.
What property?
Commutative.
Commutative. And as long as you can follow a property, it's totally legal. The only thing you can't commute over is division and subtraction. You can't commute over subtraction unless you change the sign. So 3 sections in this book are technically about the same, doing the same things over and over and over again. So how about on page 287, ooh, that looks horrible. Try number 14. Oops. Let's see, 14. 27x cubed plus 64y cubed. It's really not that hard, it's just where you're paying attention. Why would you separate it like that? Now. No. Well. Write it down. You're waiting for me. What's the point of that? And I'm doing it, not you. What are we going to write? That t squared. Okay. Now. Not plus.
Oh, I was going to choose the sign.
You got to change the sign.
And then you have to add plus 5 and cos.
Ready? 27. How do you want to write it? 3 cubed. X cubed. Plus 64.
4 cubed.
4 cubed. Y cubed. And you get it written as perfect cubes. Your next step is to basically just wipe out all the cubes. And your first term is going to become 3x
Plus 4y.
plus 4y. Then what?
That's how we do it.
You wrote 2 binomials. Square the first one. You square the first one, this first term becomes 9x squared. Then what? Multiply the 2 terms together in that binomial and you get 3x times 4x, better known as 12xy. What sign? Minus. This is always going to be opposite. Last term. Square it. So it'd be plus
16
y squared. When you're factoring a perfect cube, you have to realize that part of your answer is a binomial. The other part of your answer is a trinomial. You've got to go looking for both pieces. If you make them both binomials, then, well, that's wrong. All right. Let's try another perfect cube.
Which one?
I'm looking. I don't have time to do that. Oh, that's boring. I'm going to have to back up. Number 44 on 282. 64x cubed plus 125. It's on the previous section. I couldn't find it. No, this will still work. Yeah, do this one. 64. I don't know where my eye wandered. Oh, I was looking at 43. Play with that one. All right, 64. How do you write it? This is 4 cubed, x cubed, plus 5 cubed. And then it breaks up into 4x plus 5. Square the first term. 16x squared. Multiply the two terms together. 20x, what kind of sign? Minus, because this one is plus. And then finally, plus 25. Yay, that's not that bad, right? All right, try x to the 6 minus 64. X to the 6 minus 64.
Where did you get that problem
I made it up.
from? No, number 44.
It was a mix of 43 and 44.
Oh,
My eye wandered. I'm getting old. Done? You done? Now, is this the difference of perfect squares, or is it the difference of perfect cubes?
Squares, I think.
And cubes. So you get a choice here. Which one's easier to work with? I think the squares too. So if we deal with this as perfect squares, I'm just curious now. This would become, what times what gives you x to the 6?
X to the third.
X to the third. 64? 8, so this would be minus 8. And then the next one would be x cubed plus 8. I made a horrible problem. Am I done? No. So, these are difference of perfect cubes. So, how do I rewrite x cubed minus 8? Well, that's x cubed minus 2 cubed. So the first one is going to become x minus 2 times, no, that's different squared. X squared, the first term squared, plus 2x. You gotta multiply those two together. And then finally, plus 4. So that would be the first one. It would be x minus 2, x squared plus 2x plus 4. What about the second one here? What would be the first binomial? Oh, x cubed plus 2 cubed. So this first one becomes x plus 2. The trinomial part. X squared.
No, minus 2x.
Minus 2x plus 4. That's as far as you can go. Now, I'm interested. What if we treat this as perfect cubes? What would happen? I think it actually makes it worse. X cubed minus 64. This first term would be x. The second term would be 4. Wait a minute. It's x to the 6. First term would be x squared. Right? And then left behind would have been x to the fourth.
Well, that'd be x squared for.
Because to write this as a perfect cubed, it would be x squared cubed. All right, so it would be x to the fourth. Multiply these two together,
4x squared.
plus 4x squared. And then finally, square the last term,
Plus 16.
plus 16. All right, this gives us the x minus 2 and the x plus 2, but I don't see quickly how these two come out of it. Somehow this factors into those two. Factors of 16 that add up to 4. They don't exist. So we don't have a technique to factor this, but over here, obviously, it does factor. So in this case, it would have been better just to choose the perfect square and then the perfect cube. Kind of interesting. I didn't think that would happen. Wasn't sure what would happen. That's why I like doing some of these problems.